Hi, this is Jim Walsh, Product Manager for MACTrak Return Path Products for JDSU. Objective of today's approximately 30-minute webcast is to give brief introductory user training for WebView 2.5, the newest release from JDSU. We will not cover a lot of the advanced features in this introductory session. Stay tuned for future training sessions for more information on the advanced capabilities of 2.5 beyond what we'll show you today. Also, will not cover a lot of the deep theory behind linear impairments, things like group delay, micro-reflections, and in-band response. If you wish to learn more about these on your own, I highly recommend a series of web publications from a gentleman from Cisco by the name of Ron Ranac, H-R-A-N-A-C. If you Google Ranac linear impairments, you can find a lot of very easy to read, 10 to 15 minute read articles that'll give you a lot of good background on linear impairments, like the fact that they do not follow the funnel effect, like ingress, the fact that they're invisible to spectrum analyzers, and what a lot of the common causes of these are and how they're fixed. So I would highly recommend the Ranac articles if you want more information on that. So with that, we'll jump right in and take a look at WebView 2.5. For those of you who are existing WebView customers, WebView users, then this screen should look very familiar. A couple small changes in names of things, but generally everything is in the same spot as it was. So most of the features we're going to talk about today are in the MACTrak Analyzer. So if you click on this link here, then that will launch a MACTrak Analyzer session. From there you choose the HCU containing the node you're interested in, or you could have also searched for it from the previous screen. Then you pick the port that you're after. Only RPM 3000 ports will show up in the previous screen because only nodes monitored by RPM 3000s have these capabilities available to them. So for those of you who are current MACTrak Analyzer users in the previous versions of MACTrak are probably used to seeing a screen like this, where you need to know the center frequency, carrier level, modulation type, and so on and so forth to launch a QAM Analyzer session. New in 2.5 is an automatic channel scan feature where MACTrak will go out once per day and scan every port on every RPM 3000 card looking for carriers. When it finds a carrier, it will add it to this list of possible carriers for that port and fill in all the information that you need. MACTrak is the ability of MACTrak to be able to deliver the MAC address for each packet demodulated, as well as determine if you have any code word errors within that packet. You should see a yes under the MACTrak available. If you don't, it means that MACTrak hasn't matched a carrier that it detected with a training model that it has internal to it. So if either you don't see a carrier here that you believe should be here, or you do not see MACTrak available, you can right click anywhere out here in the white and then scan for upstream channels. And what this will do is this will force a scan like what MACTrak does every night, but force it to do it on the spot. If you try that a couple times and do not get a MACTrak available, please contact your MACTrak system admin to make sure that the system has been trained properly for that carrier type. So in this case, we're going to look at a 64 QAM carrier. So we choose the carrier and press OK. After you do that, then the MACTrak Analyzer will open and start demodulating packets. Now, common question, do we demodulate every single packet that comes across the HFC? Answer is no. We're grabbing at most 2 packets per second, depending on connection speed of your WebView client, depending on a lot of things. So it is just a sample. So the strip chart here should look familiar to existing MACTrak users, other than the fact it goes left to right instead of right to left now, and there's an extra line on it. The bottom line is carrier level. This is the level of each packet as it's received by MACTrak and demodulated. The y-axis for that is over here on the right, although I find it much easier to just hover the mouse over this line and over any specific packet you want to look at to see the level. And in addition, you can see the MAC address, the time it was demodulated, other information about that packet. Why is this level line here? What are you looking for? You're mainly looking for outliers. Do you have any modems that are coming in hot, that are broadcasting hotter than they should be, therefore coming in at a higher level than the rest? Or what you'll more commonly see is modems below this line, individual points dipping down below this line. That's an example of most often a modem that is transmitting at max and is not able to reach the head end at the desired level due to either impairments in the plant or frequently in the in-home wiring. So that is the level line and what you're looking for that. The gold colored line here is unequalized MER. The pink line is new for PathTrack WebView 2.5, which is your equalized MER. What's the difference? Well, as its name implies, unequalized is the MER of each packet as it's received by PathTrack, or for that matter, as it's received by the CMTS. This is all the computations done on the signal as received before any correction is done excuse me, by the CMTS for things like linear impairments, group delay, microreflections, in-band response issues, or constant ingress. If you have an always-on ingress source underneath your carrier, the CMTS does a pretty good job of correcting for that. So that's unequalized MER. Equalized MER, as the name implies, is the MER after the CMTS has done all of its corrections. The QAM analyzer has an algorithm that works largely the same as an equalizer within a CMTS to correct for those types of impairments that I mentioned previously. So which line's more important? Which line should you care about? Depends on what you're doing. So the unequalized MER is a very good way to see the raw health of the plant. It doesn't candy code it like the equalized MER does. It tells you where your weakest points are, the modems that have your lowest MER, if it is a problem that is can be specific to a certain section of plant, like a linear impairment. The equalized MER is valuable because it tells you the condition of your plant as seen by your customer. So if you have a really low unequalized MER, but the equalized MER is good, it means you're stressing your equalizer pretty hard in the CMTS, but at this point in time, it's still fixing things, so your customer probably isn't noticing the effects of whatever the impairment that's present is. So which one do you care about? It depends. Probably both. The other field here in the strip chart is the MAC address. So this tells you the MAC address of each packet as it's demodulated. And whether this is a CPE MAC or cable modem MAC also depends on what you're doing. I'll cover that here in a little bit in PowerPoint form. Over here you see the constellation looks similar to what you're used to seeing in PathTrack, other than you have more colors of symbols. And to better demonstrate why, I'll jump over to the 16 QAM carrier on this same node. And helps because the symbols are spread out better. So what you're looking at here is, I'll pause it, the orange symbols are your unequalized symbol locations. The yellow dots are your equalized symbol locations. So if you take a look at some of these packets with low MER, low unequalized MER, you see a pretty good spread in the orange, but much tighter in the yellow. So the equalizer is fixing essentially the whatever the impairment is. Now here, if we go to some packets that have higher MER, you see a much tighter constellation. You can use this drop down here to determine what you're looking at. Do you want to see just your latest unequalized symbols, so only the orange dots, one packet at a time? Do you want to see all unequalized symbols, so this is every packet that has been demodulated in this session stacked on top of one another? I tend to prefer latest symbols. There are others who will prefer just seeing the latest equalized symbols, because all that is important to them based on their job function is what the customer is seeing. So as you can see, you get a much tighter constellation when you're just looking at equalized. So I think you get the gist of all the different choices you have here. I tend to prefer latest, where you see both equalized and unequalized. Just something you have to train your eye to look at. You notice I used the pause button here to pause a session. So if you do that, you can either use the arrow keys here on the QAM analyzer, or you can use the arrow keys in your keyboard, or you can drag the marker to go back in time and see what the constellation looked like for any packet back in time. So a neat feature of being able to navigate back through, as well as see the MAC address for each packet. A neat feature to be able to go back in time and see what had happened within this given QAM analyzer session. Now the next thing you may notice here is the spectrum analyzer that has been integrated into the QAM analyzer display. We noticed when people would use our previous generation QAM analyzer, they would frequently have it open in a half-size window and have a spectrum analyzer open next to it. And this is done for good reason, because while the QAM analyzer's primary function in life is to tell you what the health of your carrier itself is, the spectrum analyzer also tells you a lot of information about what's going on in the spectrum outside of your carrier. So to demonstrate that, I'll go ahead and I'll open up a spectrum analyzer on the same node we were looking at, CO53, and we'll wait for that to load. But you'll notice here that you don't see any of the bursty lines underneath the carrier that you normally see on a standard PathTrack spectrum analyzer. See here, you see individual lines bursting in as underneath the carrier. And the reason why that is, for this standard PathTrack spectrum analyzer, the way this is built is PathTrack scans across the entire frequency range that you're looking at for your spectrum and takes a whole bunch of discrete level measurements, stacks them all together to form a spectrum analyzer. In the carrier spectrum display of the QAM analyzer, PathTrack will go out and take one snapshot of the entire spectrum, digitize it, and then draw the display all at once. So you don't see the burstiness of the lines underneath the carrier that you're used to seeing, not because this carrier is really busy, but more just the difference in the way that the spectrum analyzers are drawn. So just be aware of that. They're generally going to give you the same appearance. The overall spectrum will look about the same between the two analyzers. You see the same peaks present, but they will look different if you have two people on different ends of the phone trying to discuss it. The other important point to note about the carrier spectrum display is this is only capturing the spectrum when we demodulate a packet. The standard PathTrack swept spectrum analyzer is just constantly scanning, independent of when modems are transmitting or when PathTrack is demodulating packets. So the neat thing about that is if you pause this, you can go back in time. And actually I saw an interesting one earlier today where you can see I'm stepping my cursor forward and backwards in time here, and you can see at some point in time we had a big blast of ingress come in. And a likely candidate for that would be this low MER point here. So if we step back our strip chart to bam, where that low MER point is, you can see, wow, yeah, that's where my spectrum ramped way up. Here is the modem who was talking when that happened. I wouldn't glean a whole lot from that, because if it is an ingress issue that follows the funnel effect, it's just a matter of chance which modem is talking. Can't necessarily glean that that modem has anything to do with that problem, but this is just an illustration of you can step back in time and you can see what your constellation looked like and what your spectrum looked like at any point in the past during the QAM analyzer session that you have open at the moment. So another frequently asked question is, does this spectrum analyzer count against your 2 simultaneous spectrum analyzers per card limit? The answer to that is no. You can have 2 simultaneous QAM analyzers and 2 simultaneous spectrum analyzers open per card. So you can think of this as 2 free spectrum analyzers on your card as well. So that is the main points of the strip chart, the constellation, and the carrier spectrum display for WebView 2.5. Next, I'll jump off to PowerPoint to talk about the next section, which is the impairment dashboard. That is this section over here on the left side of the display. And in a gist, the WebView 2.5 is a very complicated tool with a lot of advanced capabilities, so we wanted a very simple display to help less experienced, less advanced users know at a glance, do they have a problem on their node? And if they have a problem, what type of problem is it what type of impairment is it that's likely causing that problem? So that's where we came up with the concept of the impairment dashboard. The impairment dashboard has 2 main sections. The top section consists of your health metrics. It doesn't tell you a thing about what is wrong with your node, it just tells you if you have a problem. It gives you an idea of code word errors. Do you have data corruption within packets as indicated by code word errors? And do you have other impairments that are causing a spread in your constellation? More symbol error, like the equalized and unequalized MER. The bottom 6 buttons indicate how frequently each type of impairment is occurring. What you're trying to get at here is which impairments are my biggest problems right now. If you have something turning red up here, a problem with one of your health metrics, what are the most likely impairments to be causing that? Now there's a lot of information contained within each one of these buttons. You see a lot of text here. So to deep dive into that, we'll take a look at the contents of each piece of this button. So the upper left-hand corner is the label. What is the button? Self-explanatory. The background color is the status, and you'll hear me talk about a packet that passes or fails a threshold for, in this case, a given health metric, or for the case of the bottom 6, a different impairment. Your PathTrack administrator will set up thresholds when they set up their WebView server the first time and say, here's what I consider good and bad for code word errors, equalized and unequalized MER, and all 6 impairments. The default for these, as it will ship from the factory, is either DOCSIS spec or some offset from DOCSIS spec that is set by JDSU based on the field experience that we had to date, but these thresholds are completely adjustable by your administrator. If a packet violates that threshold, meaning it's a bad packet, then this background will turn red for this button and stay red for the remainder of the session, with the exception of code word errors, which will toggle between red and green depending on whether the overall code word error rate for the session is above or below the threshold set by the admin. So, you can imagine that if you have one packet out of hundreds that have been demodulated in a session that fails and turns this red, you can get that by chance. And you can end up with all your buttons red if you run a session for a long time, which doesn't help you knowing what the problem is. So to that end, we added the roll-up counter. And what this tells you is what percentage of packets that have been demodulated since the session started have violated the threshold. So if you had only one packet out of a couple hundred that had failed for something, you'd only show 0.5% here. But if half of them have failed, you'd show 50%. So it's a way to tell the random one-off occurrences from the chronic problems that you're having on your node at the moment. This field here shows you the latest value. So if you're watching a QAM analyzer demodulating packets in real time, then you'll see this update. Or if you've paused and you're stepping back through time, then you will see this value for each packet, the current packet that you're looking at. Latest status here, this is just pass-fail for each packet. Does it pass or fail against the threshold? Min-max and average is relatively self-explanatory, other than the fact that there's only a 600 packet rolling buffer. So rather than going through the text, we'll talk about that here. So this strip chart is only 600 packets long. You can see now we've demodulated about 250 out of our 600. But let's say we had gone past that 600 and we had demodulated 1,300 packets. You may see, so you say, wow, this is a really low unequalized MER, 22.23. I want to go find that low MER packet and see what MAC it's from and what was wrong with it. If it isn't within the most recent 600 packets, it may have rolled off the left edge of the strip chart and be gone. So just be aware of that. Don't drive yourself nuts looking for that. A simpler way to look for, let's say we wanted to find this 22.33 MER packet, is I would pause the session and I would go to a data table view, which is this button here. By default, you start in strip chart view. You can go to this data table view and you can sort any one of these fields. And this is lowest to highest, the arrow pointing that direction, much like in Excel. So if I do that, aha, there's my 22.33, there's the MAC that it's from. It tells you more information about that. Now there's also another data table, the unique MAC view. So to talk about those, I'll jump out again to the PowerPoint presentation. We'll spend a little bit of time on this because this can be confusing. So remember, there's the strip chart view is the default. If you choose the per packet view, you get a table that looks like this. Very important to remember, one row equals one demodulated packet in this table. So this entire row right here is telling you all the pertinent information for packet that was demodulated at 3:03 p.m. from MAC address ending in 9D00. It had no code word errors. Its unequalized MER was 28.3. Its group delay was 218.4 nanoseconds per megahertz. Now the background is red on this cell because for this individual packet, the group delay that was measured violated the threshold that was set by the admin. Therefore, it's red. So remember, one row equals one demodulated packet. Each row is a separate packet. Now if you were to click on this other button, the far right hand button, this gives you the unique MAC view table. In this case, one row equals all the information for all packets demodulated from a given MAC address. So one row equals one unique MAC address. In this example, we're looking at a summary of all packets demodulated from MAC address ending in D9A6. We demodulated 19 packets from him. He was 45% of all packets during this session, so he was pretty chatty. He was almost half the packets. 10% of his packets had code word errors. His worst case MER, his worst unequalized MER of all 19 packets was 25.19. His worst group delay was 242.3. Now, did this MER and this group delay occur on the same packet? Maybe, but not necessarily. Remember, one row is a summary of all packets that were demodulated from that MAC address during this given session. So those are the data tables. So how would you use these data tables? When would these be useful? An example of that would be, take for example this session that was captured earlier. In this specific case, same node, CO53 again, the impairment dashboard said, aha, you have a code word error problem. You also have an equalized and unequalized MER problem, but code word errors, given that they are an indicator that you have corruption of data within your packets, are the most severe, the thing I'm going to care about here. And about 2% of our packets contained at least one code word error. When I look at my impairment dashboard down here, I say, well, everything's green except for impulse noise, and about twice as many packets failed for impulse noise as code word errors. I'm guessing that I have an impulse noise problem. Looking at the max hold on my spectrum, which by the way can be turned off by right-clicking out here in the spectrum if desired. Same for min hold. By looking at that, it looks like I have an impulse noise problem. But if I wanted to drill down in more detail, I would go to my table view and I would sort by total code word errors and say, okay, if I want to look at the packets that had code word errors, what was the problem with them? Oh, aha! I see every single packet that had a code word error failed for impulse noise. And when I click on the spectrum for one of those, wow, look at that spectrum during that time. I would say that definitely got hit by impulse noise. So this tells me, yes, I am having a code word error problem on this node right now. And the most likely cause of this problem is impulse noise. That's the problem that I need to go out and chase. So that is one way that you could use the table to know if you have a problem on a node, and if so, what the problem is. Now, let's say that the problem that you are seeing was a group delay problem. So, yeah, we have a handful of packets failing here for microreflections. We'll use this example. So if we go to our table view, see, yep, I have 14% of packets failing for microreflections. And I sort by microreflections, what do I find? I find that I sorted in the wrong direction. So I find that, okay, most of the packets that I have failing for microreflections seem to be all from the same modem. You can see the MAC address here for the packets as they come in, and they are all from the same modem, just about all the fails. So you say, okay, this is probably a localized problem to this one given customer, but he's a vast majority of the microreflection fails. Let's make sure he's not a vast majority of the overall packets as well that could throw us off. And lo and behold, no, he's only 11% of the packets, B03A, yet he is the vast majority of microreflection. So in this case, if this were if you wanted to go off and solve the microreflection problem on this node, given that microreflections can be localized to a section of the plant, they will only affect the source of the microreflection back, will not affect other modems, then you would want to know the street address to roll a truck to solve this problem. So in this case, you can right-click on the modem and copy this MAC address to clipboard. Then you can paste that into your in-house system to either convert it to a cable modem MAC and then street address if that step is necessary, or you can get it directly to a street address depending on your back office system. Now notice I said that is a CPE MAC. Why did I say that? In order to understand which MAC address MACTrak is getting from the HFC, you have to understand how DOCSIS packets work. So in a standard mode where a guy is sitting at home browsing the web, his web browser, when he sends a request for a page request out to the internet, his browser will send a request to the cable modem and say, hey, please transmit this packet onto the HFC to get it out to the internet for me. I want this page. So the cable modem will hear that. He will embed this guy's MAC address into the packet so he knows where to send the packet when it comes back, and then broadcast it out onto the web. Because this CPE MAC is what is in the packet that gets broadcast, that's what PathTrak will see. So in that case, we'll be getting the CPE MAC. A more common case is where you have a router behind a cable modem. Again, you have the PC, the guy's browsing the web, browser sends a request to the router, then the router says, okay, Mr. Modem, please send this packet out onto the HFC for me. Modem says, okay, I hear you, I know what your MAC is, Mr. Router, I'll send that packet out on the web for you. In that case, PathTrak would get the router MAC, which to your CMTS and to your back office systems is the CPE MAC, so it's still not a big deal. You just have to get from CPE MAC to cable modem MAC to generally to get into the billing system and get the street address for that packet. EMTAs work similarly. An EMTA will have a cable modem MAC and an EMTA MAC. So if someone is just browsing the web from their PC, you'll be seeing the CPE MAC from this PC. If they're on a VoIP call, the EMTA section of this device will send a request to the cable modem section of the device to send the VoIP packet out on the web. In that case, during a VoIP call, you'll be seeing the EMTA MAC. Again, CMTS sees that as a CPE MAC, so your back office systems will report that. If you want to look that up, it'll be reported as a CPE MAC as well. So, in all those cases, you'll be seeing some version of the CPE MAC. When will you see something different? Well, a very common use case is if you want to see packets from a customer's site. If that customer is not online and talking, then you need to do something to generate traffic from their modem for PathTrak to see it. In that case, you can ping using a fast ping utility like the Colasoft ping tool or fping as in fast ping to generate really fast pings to the modem so that the modem can be talking so that PathTrak can see it. When you're pinging the modem, he is sending packets out onto the HFC on behalf of himself, not any of the CPE behind him. So in that case, you'll be looking at the cable modem MAC. So why would you do this? A very common use case is the intermittent truck roll use case, where you have that small percentage of customers that keep calling in, they keep having problems, you've replaced their modem, you've replaced their drop a couple times, you can't seem to figure out what's wrong. In that case, how you'd use the MACTrak analyzer is you would get that customer's cable modem MAC from your trouble ticket or from your billing system, wherever you need to get it from, and you'd get his IP address and you'd ping the cable modem itself. That would generate traffic. You would go into your MACTrak analyzer, and in the MACTrak analyzer, using this button here, the settings button, which is also a button that you would use if you wanted to change which carrier you were looking at, but you go into that and you go to the filter tab, and you can filter on that customer's MAC address. So you would paste their MAC address in here, then you would only be looking at packets from that customer's MAC. So you can see, is there a problem with that customer's service right now? Am I seeing code word errors? If so, what is causing the code word errors? Use the impairment dashboard to tell you, aha, here's what the problem with this customer is. Now, being an intermittent problem, chances are you're not going to see it right at that instant. Unless it is a linear impairment or something that's always there that is stressing the CMTS, that is making you more prone to code word errors. In that case, you could potentially proactively go after the problem. But if you didn't see it, remembering that there's only a 600 packet buffer, if you wanted to leave this session running for a long time and only wanted to capture packets that had code word errors from that guy so that they wouldn't roll off, you could capture a whole bunch of packets with code word errors to understand what the problem is. You could go back into your filter and not only filter on his MAC address, but also say, I only want to see packets that have code word errors. If you do that and run a session for an extended period of time, when this customer's problem does pop up, you'll capture packets from it to know, one, when the problem occurs, and two, by using the impairment dashboard, you can step back through and determine what the problem is that is causing that customer service issue. So that is an example of a time when you would be pinging, you would be seeing traffic from the customer's cable modem, you would filter on the cable modem MAC and see what their problem is when it occurs. Last example I'll show you is if you're using a DSAM. So remember, a DSAM can be ranged and registered online just like a cable modem. It is a cable modem. So if you're doing this, if you're trying to segment a linear impairment down to its final location, or if you're trying to pre-qualify spectrum from any point out in the head end, any point out in the field back to the head end for say 64 QAM turnup, then in that case you would ping from your DSAM using the ping feature of your DSAM. And if you're doing that, then you would see the DSAM's CPE MAC. And a secret hint of how to find that in the QAM analyzer, if you didn't remember to write it down from your DSAM range and register setup screens, is it'll always begin with 0007. So usually you'll be the only DSAM talking on a node. So when would you want to filter on your DSAM's MAC? Remember I had talked about previously segmenting a linear impairment with this. In the group delay example I showed before, you could get the MAC address of a cable modem or small group of cable modems or CPE MACs that were affected. If you looked up those CPE MACs and found there were 3 affected and they were all geographically close to one another, you would likely roll a truck out to the least common denominator component, say a tap that all 3 of those were off of, or the last amp that was common to all 3 of those MAC addresses. From there, you could take your DSAM, range and register it online, and essentially do divide and conquer in reverse. You could start at the southernmost seizure screw port of the tap and range and register your DSAM, filter the MACTrak analyzer on just your DSAM's MAC, look at its packets, say, do I see this microreflection problem from here? If you do, then you go one step closer to the head end, the northmost seizure screw port, which I found that if you take less than 5 seconds to go port to port, you don't need to rearrange and register. You can very quickly determine at both sides of a tap or both sides of an amp, seizure screw ports of an amp, do I have the problem here, do I have it there? So you do this until you get back to the point where you no longer see that linear impairment. When you do that, you've now isolated it down to the component at fault. Once you have found and fixed the problem from that point, you could either take your DSAM back to the last known bad point, ping from your DSAM to verify via the constellation and via the code word error detection that you have truly fixed the problem. And then if you want to do an absolute check of it, you could ping one of the customer's cable modems who was having a problem before and use actual customer modem packets to verify that you have truly fixed the problem. So those are examples of how you'd use the MACTrak analyzer to solve some of your most difficult problems, how you can filter using the MACTrak analyzer, and the objectives of the impairment dashboard, how to use data tables, and sort. Again, this was intended to be a very high-level training. There are detailed impairment charts available that can be accessed by clicking on any one of these buttons or clicking on this tile button here to see detailed impairment charts for each one of these impairments. Stay tuned for a future training class where I will spend more time and get into some of these advanced features once people have had time to digest what's in MACTrak today. Thank you for your time.